All right, guys, this is the second part of this urbanization and water use lecture that I want to give. Yesterday, just a quick review from yesterday before we get into today's stuff. But yesterday, we talked a little bit about urbanization and urban sprawl and sort of the impacts that has on water use. At least we started talking about that. One of the things from yesterday I want to make sure you guys remember is groundwater, right? What groundwater is, what an aquifer is, the two different types of aquifers that are clearly shown in this picture. I lectured over this yesterday. Make sure you read through this, make sure you know or can kind of contrast an unconfined aquifer and a confined aquifer. Specifically, I talked about the Ogallala aquifer yesterday and why that one is kind of important to sort of remember something about. Cones of depression. I said that these can form anytime somebody overdraws water out of a well. So kind of make sure we know the repercussions of a cone of depression. And then we kind of talked about saltwater intrusion as well. Make sure we know where this occurs at and two different ways that it can actually happen. So know what it is, where it can occur, and how it can happen. Then we concluded yesterday with how urban areas or how urbanization, I should say, kind of affects the water cycle. So we talked about three different ways that could happen. All right, now today we're going to focus on, how we have kind of learned to live, with water or without water. We've done a lot of things over the last several hundred years, as we've become more urbanized and even spread out to create suburbs. We've gotten pretty creative with our use of water, and we're going to talk about a couple different ways that we've kind of been able to access water and move water around on our planet so that people can gain access to it. We're going to talk about something called levees, dikes, dams, aqueducts, and then a process called desalinization of water, which is basically how you can take salt water and turn it into fresh water, because that's something that we can do, but it's a really slow process, and we'll talk about some of the pros and cons with that. All right, levees. Levees are basically used, and they can be natural or they can be man-made. A lot of them are man-made. But these are basically just structures that are built on the sides of rivers to prevent flooding. I'm gonna go back to this picture real quick. This is Pittsburgh, Pennsylvania. Pittsburgh is basically a city that's built near three different rivers, and in order for that city to thrive, they have to make sure that the city doesn't flood, if those rivers were to overflow or if there was a torrential rainfall or something. So like most cities that are built near rivers, they build these levees. And these levees are built to kind of, block any rising level of water in the river or any other body of water that might be near it. So, for example, right here, this picture on the bottom, this is showing you something what we call a floodplain. Floodplain is basically the land that is near a river. It's near or it's adjacent to a river where, if that river were to overflow, that floodplain land would be flooded. The one thing about floodplain land, which is kind of interesting, is because it's so prone to flooding. All of that water from a river, if it does wash up onto land, that river water contains a ton of nutrients, which makes that floodplain land some of the most fertile, some of the best agricultural land that we have on Earth. So it probably is, again, no surprise that, hundreds and hundreds of years ago, the settlers of a lot of our cities near rivers moved there because not only is there an access to water, but there's an access to fertile soil to grow crops. So that kind of makes a lot of sense. The Mississippi River, which is the longest river in our country by far, contains over 1,500 miles of levees just because there's a lot of people that live along the sides of that river. And if those levees aren't in place, then flooding can occur, which could impact their lives, could flood their homes, flood their neighborhoods. Now, the downfall, I suppose, with building a levee is you don't kind of allow that natural water to which carries a bunch of nutrients to flood the land and make the land fertile. We're showing the formation of a natural levee. For example, here's the land on both sides. This is floodplain land here, right? And so when that water overflows, all of those sediments and all of the nutrients get dropped on the land. Now, yeah, that does make the land fertile, but it also deposits sediments on the sides of the river. And over time, those sediments build up and build up and build up, and they just kind of form a natural levee. But again, that natural levee is going to eventually block any further flooding episodes that might happen. So again, that does occur naturally, but a lot of times these levees are man-made. Like we build structures to actually block that water from overflowing. All right, challenges of levees. One of the big things with this is, by building all of these levees, again, we do kind of inhibit, the natural ability of that river water to, irrigate the land and fertilize the soil. So, if we're building these levees to block that, then we're actually making, less fertile soil by doing that. Another big problem with levees is because a lot of that sediment can't come up onto the surface. It can't come up onto the floodplain. A lot of those sediments will just travel down the river. And when they travel down the river, eventually they're going to be deposited somewhere. And if that happens, that can block the outflow of the river, and that can result in flooding as well. So we got to be really careful with all these sediments that travel down the river. If they're not allowed to wash up on the floodplain, then they're going to be going somewhere else, and that could result in flooding. Again, there's lots of housing developments near floodplains. So if a levee breaks, that could cause neighborhoods to flood. In some cases, cities to flood. This is Hurricane Katrina back in 2005. You guys, well, I don't know. You guys were probably not even born yet, I guess. Some of my students now, I guess that's kind of hard for me to believe. But anyway, Hurricane Katrina happened in 2005, and this happened in New Orleans. And here, this picture, what you're seeing is, this is a little waterway, a little offshoot of a river, the Mississippi River, and you see that the levees here broke. These walls here are what kind of holds back the river. You see that it didn't really break on the other side, but it did here. And we look at these houses and look at the flooding that resulted. This was such a massive event. 1,800 people died. $80 billion of damage to the city. I mean, this was like a massive disaster. Here was New Orleans. Here, these areas in yellow are where the levees actually broke and caused neighborhoods to flood. You see it here again. The picture on the left is kind of the before picture. Picture on the right is what happened after Hurricane Katrina. So, I mean, a lot of this, this wasn't like a slow thing. Like this was like a very fast event. So people they literally drowned because they couldn't get out of their homes fast enough. And it was just this huge, huge disaster. Dikes. Dikes are kind of similar to levees, but instead of blocking river water, they block ocean water. And again, a lot of them are man-made, some of them are natural. They're really common in Northern Europe, the Netherlands, for example. 30% of the land in the Netherlands is below sea level, so they have to have these dikes built to kind of block that ocean surge that might eventually get up onto land. So, again, a dike is similar to a levee. A dam. A dam is just a barrier that runs across a river. Again, these are man-made structures. We're talking man-made dams, not like a beaver dam or something. A couple terms here. A reservoir. This is the water that gets stored behind the dam. Right, the dam is built, and the dam can open and close and allow water to travel through, or it can block the water from traveling through. In the U.S., we have over 80,000 dams, and they're built for a couple of different reasons. They're built to to hold water back, either for human consumption. In a lot of cases, they're used to generate electricity. They're also used to help control flooding downstream, and they're also just they're used for recreational purposes as well, to back water up and to have it be like a reservoir for boating and fishing and whatever. But I would say these first three things are probably a lot more common than the fourth one is. This is Three Gorges Dam. The reason why I just want to bring this one up is because it is the largest dam in the world. It's 1.3 miles wide. It took 13 years to construct. The reservoir behind the dam is 400 miles long. There's some pros and cons with it. I guess the big benefit is it's a hydroelectric dam, so it produces a ton of electricity without using any fossil fuels. And that's kind of a big issue, which we'll talk about in the next unit. But this thing is used to generate a tremendous amount of electricity. Oh, by the way, this thing is in China. I should probably have written that on here, but anyway, it produces a lot of electricity for China. One of the big problems with it was when the construction was built. It actually forced 1 million people out of their homes to relocate somewhere because of all the flooding behind the dam. They built this reservoir, because they blocked the river, and it literally just flooded everywhere, and 1 million people had to kind of relocate because of that. Some environmental problems with dams. They do disrupt the natural flow of water. So, anytime you're blocking the water flow, that disrupts habitat. So we can disrupt wildlife, fragment habitats. We've talked about fish ladders before. If all of a sudden you're blocking the river, then you're blocking the natural migration of organisms, and one of those might be fish, like salmon. So if you build these fish ladders, it kind of allows them to get to the other side of the river. They actually will kind of climb these stairs. Fish will do that in order to get to the other side, in order to breed or to spawn or whatever. So that's one way, I guess, we can kind of help the fish a little bit. Aqueducts. Aqueducts are man-made, um, either tunnels or canals or ditches that are used to carry water from point A to point B. A lot of our cities in our country, like especially like New York and Los Angeles, a lot of those cities, depend on water sources from outside the city. For example, this picture on the bottom left is showing you the construction of something called the Catskill Aqueduct, which is basically a series of kind of underground pipes that carry water from the top of the Catskill Mountains, which are in kind of upstate New York. And when that ice melts, all that water travels to the city of New York. So it's just a kind of a man-made kind of tunnel system to move water from point A to point B. The picture on the right is showing us the Colorado River Aqueduct, which is kind of an external, kind of an above ground aqueduct that carries water to the city of Los Angeles. You can imagine the manpower and the energy and the time that it takes to build these aqueducts, especially if they're large, several mile, operations. It does take a while to do that. But, and again, fragmenting habitat, all those types of things kind of come into play as well. So some issues with aqueducts. Construction's pretty expensive. Disrupts natural habitats. Anytime we move water, from one area to another, that can lead to the drying up of rivers and drying up of lakes because we're diverting it, we're moving it to an area where it normally doesn't move to. If aqueducts are open, like exposed to the elements, they can lose a lot of water to evaporation, so that wouldn't be very efficient. And also, diverting water can affect other regions, which we'll talk about more in a couple of minutes. Here's an example of water diversion, moving water that kind of went wrong. This is called the Aral Sea. This is in Russia. The Aral Sea, the picture on the left here, this was taken in 1989. This was once a large freshwater lake, and you can see kind of how big it is. But what they decided to do was they decided to divert the water. So they basically built an aqueduct system that carried water from this region to farming regions around the area. I believe they were trying to farm or grow cotton or something. I can't remember what it was. But they basically just drained this thing for irrigation purposes. And the picture that you see on the right, this was taken in 2014, is basically what was left of the Aral Sea. So we kind of diverted this water away to use it for other purposes, and you can kind of see what the result of that was. 80% of the lake is completely gone, and what was left behind was a tremendous amount of salt. Now, even though this was not a saltwater lake, there is there is salt in it. It's just not enough to call it a saltwater lake. So when they moved all of that water out of there and it left behind all that solid salt, now all of that salt actually can get whisked up into the air through just erosion. And now in this area, they have a lot of air pollution problems because people are breathing in all of this like salt and dust that's just kind of left behind from the Aral Sea basically being dried up. So kind of a problem there. That is and or was and still is an issue. Here's another example of water diversion and how it can affect different areas and different regions. This is the Ganges River. I'm not sure if you're familiar with it or not. Maybe you've heard of it before. But the Ganges River actually travels through two different countries. It travels through India, kind of the northern part of India, and it travels through a smaller country called Bangladesh. And then it kind of empties out into this body of water called the Bay of Bengal, which is in the Indian Ocean. Now, the water kind of travels in this direction. It kind of empties out from the mountains here, and then just kind of again just travels through two different countries. Now, India, in 1974, they decided that in their country, they wanted to help out the local farmers, especially in the northern region of the state. So I'm going to go back to this picture here. And what they did was they built some aqueducts, they built some natural water diversions to where, instead of the water flowing all the way through to Bangladesh, they built these little, if I can draw it in for you here. They built these little diversions. Oops, sorry. So like the water would, for example, come down this way, or the water would come down this way, or it might even go up this way, or down this way. And that water would be carried to different farmers or to just different areas around India, so people could use that water either for irrigation purposes or whatever. Now that's all good and great. I mean, because in northern India, having more access to water is probably a good thing. Now, another thing about India and how they use the Ganges River, a lot of their waste ends up getting into the Ganges River. Either waste from factories or waste from their homes. A lot of this picture here that you see is part of the Ganges River, and you can see just all the pollution that people from India just kind of use this river for. It's one of the most polluted rivers in the world. Now think about how this affects Bangladesh, right? I mean, up here is where all the diversion happens and where all the waste problems happen. But all of that water is going to travel into the country of Bangladesh. All this dirty water, all this wastewater. Now, because the water was diverted and moved like in different directions, it actually reduces the amount of water that actually makes its way to Bangladesh. So, if you live in Bangladesh and you're a farmer and you rely on that water from the Ganges River, well, because India diverted the water, now you're not getting as much water as you normally would. So the farmers in Bangladesh really suffered because of the actions that India took. Another big problem is fishing. If you have less water flow, coming into the country, that's going to impact fish stocks. So if you're a Bangladeshian, fisherman, your life was probably impacted. Another big issue is the river, and we talked about this yesterday, is a saltwater intrusion. All of this water down here, this is all saltwater, right? That's part of the Indian Ocean. The river is carrying fresh water. So right in this area, right in here, is kind of where the fresh water and the salt water meets. Well, if the fresh water is not flowing at the rate that it used to flow, then this salt water is actually making its way further up the river. So there's more saltwater intrusion moving up the mouth of that river than there ever has been before, and it's all because of what India decided to do, with the water. So I guess this kind of brings us to this scenario. It's like, okay, here's the Ganges River. You've got these two countries that depend on the water. One country is kind of upstream, the other country is downstream. I mean, who owns this water? If one country decides to do something with this river, it can severely impact another country negatively, and it really has impacted Bangladesh. All right, the final thing that we can do with our water is, besides moving it from place to place, we can desalinize our water. This is a process of removing salt from salt water. This is a really common practice in Africa. It's a really common practice in the Middle East. Now, the reasons why is because there's just not a lot of access to fresh water in those areas. So they're kind of resorted to either getting their water from the rain, and if it doesn't rain, then they've got to do something like this, either distill their water or use a process called reverse osmosis. And I just want to explain briefly what each one of these is. This is called distillation. This is a way to remove salt water or salt from water. Basically, what they do is they have, let's see if I can get my little pointer up here again. There we go. Basically, what they have is a kind of an intake valve, where salt water will kind of come in. It'll flow into this chamber. And they have what they call a condensing coil, which basically just kind of exactly what it says is it kind of cools the water off. So this water will kind of travel down this coil. It'll travel down this chamber, and there's a heating element. So the water will basically boil. Now, if you know anything about boiling salt water, right, because that's what's coming in as salt water, all of the water will turn into vapor, and it'll leave behind all the salt. So all of that steam is going to rise, and when all that water vapor comes in contact with this cold coil, this is cold, by the way, then it'll condense. And on the other side, this is fresh water. So this is the fresh water on this side. This is the salty water on this side. But there's an outtake valve here that people can access, and they can basically have fresh water from salt water. Now, this stuff on the other side, this is extremely salty water. So that has to be dealt with, and we'll talk about that in a minute. This, on the other hand, this is called reverse osmosis, and it's kind of a similar thing. It's just a different process. The whole point of this is, again, we have salt water that comes in, so we have all these impurities in the water, and there's a membrane down the middle. There's kind of a semi-permeable membrane, and what they use is pressure to help squeeze the water through the membrane and keep the impurities like the salt on this side and the fresh water comes out the other side. The issues with both of these processes are, one, they both require electricity, so they require fossil fuels. Another thing is that they're really, really slow. It's not like you can produce a ton of fresh water quickly doing this. This is a very slow process, and it takes a long time for this to occur. The other big issue is brine water. Brine is kind of the residue that's left over. Like, for example, on the left side of this chamber, even though we're bringing in salt water and we're pushing the fresh water out, whatever's left on this side is like 100 times more concentrated with salt than what it was when it first came in. So they got to do something with all of that brine water. And what they usually do is they'll just dump it into a river or they'll just dump it into the soil. And that could lead to desalinization of the soil, or salinization of the soil, which nothing can grow in that. So that's kind of a big problem. So what to do with the brine water is kind of a massive undertaking. All right, guys, that's it for me for today. Make sure you check your agendas, and I will see you soon.